Hi and welcome to our video. And for this video, we would like to talk and discuss about the applications of differential calculus to civil engineering. But before we begin our discussion, let me introduce myself first. Hi, my name is Nor Azmina, and these are my team members Selena Chelsea and Nor Kartika. Now let's jump right into our discussion. What is the application of differentiation? Differentiation allows us to find the rate of change. For example, it allows us to find the rate of change of velocity with respect to time, which is also known as acceleration. It allows us to find the rate of change of x with respect to y, which on a graph of y against x is the gradient of the curve. There are a number of simple rules which can be used to allow us to differentiate many functions easily. Why is differentiation a compulsory topic for civil engineers? Differentiation is a technique which can be used for analyzing the way in which functions change. In particular, it measures how rapidly a function is changing at any point. In engineering applications, the function may, for example, represent the magnetic field strength of a motor, the voltage across a capacitor, and the temperature of a chemical mix. As for this case, as a civil engineer, we were given a task to build a dam for power generation. This is built on a river with a width expressed as 10 times the quantity of x squared minus 8x plus 23. And the depth of the water is expressed as 30x plus 10.
Thank you, Asmina. Hi, I'm Selena and I'm going to present to you our problem statement and solution. Question 1. If the dam cannot be more than 320 feet wide and 160 feet above the riverbed, and the top of the dam must be 20 feet above the present river water surface, what is the range of the locations that the dam can be placed? We have the width Wx is equals to 10 times the original function. Therefore, Wx is equals to 10 in the bracket x squared minus 8x plus 23. For the depth, dx is equals to 30x plus 10. The constraint or limitation of the dam is given by the depth of the dam must less or equals to 320 feet, 160 feet above riverbank, and the top must be 20 feet above the surface. Then, we will put the constraints or limitation into each functions. For width Wx, we will get equals to 10 in the bracket x squared minus 8x plus 23 must less or equals to 320 feet. Therefore, we'll get the range of x between -1 and 9. For dx, we will get the range of x less or equals to 5. Therefore, we will get the range of location for the dam, which are, for width, we will get x between -1 and 9. The depth, x is less or equals to 5. Therefore, when we combine them, we will get the range of x in between 0 and 5. And now for the fun part, which are finding maximum and minimum value by differentiation. For question 2, what are the dimensions of the widest and narrowest dam that can be constructed in accordance with the constraints? Solution for question 2. They ask, what is the widest and narrowest dam? Therefore, we know that widest and narrowest means maximum and minimum. Therefore, we will let the first derivative of x is equals to 0. So function of Wx is equals to 10 in bracket x squared minus 8x plus 23. When we differentiate, we will get 20x squared minus 80. So we let the first derivative or the prime of Wx is equals to 0. Therefore, we will get x is equals to 4. At x equals to 4, we substitute into the same function, wx. Therefore, w4 we will get 70 feet. Then, we will check the endpoint of the intervals, because just now we know that the interval, the combined interval, was x between 0 and 5. Therefore, to find the value of 0 in the width, we will get 230 feet, while for the range 5, we will get 80 feet. The conclusion is that the dam has minimum width at x equals to 4 with 70 feet and the maximum width at x equals to 0 with 230 feet. Civil engineers will have to optimize the size of the dam for cost constraints. Therefore, in question 3, we will look upon this. Question 3 asks, if the cost is proportional to the product of the width and the height of the dam, where should the most economical dam be located? The constraint is that the length of the dam must be higher than 20 feet from the depth of water there. So, firstly, we must list all the information given. The depth dx is equals to 30x plus 10 and the height hx is equals to dx plus 20. Therefore, we substitute dx into that equation, we will get hx is equals to 30x plus 30. So, given cost function is proportional to the product of height and width, we let cost equals to cx. So, cx is equals to function of the product of height and width. So, product means multiple. So, the function of cx is equals to x3 minus 7x squared plus 15x plus 23. To find the maximum and minimum value, we again let the first derivative of the function equals to 0. In this case, cos prime x is equals to 0. So we differentiate. Let's look at it. Cx is equals to the function. So when we differentiate, the power minus 1 and the original power forward go in front. Therefore, let's see x cubed. So cube go in front becomes 3 and the power of 3 minus 1 is equals to 2. The same goes to negative 7x squared. The square go in front, so 7 times 2, 14. So x to the power of 2 minus 1 is equals to x. And 15x because the power of x is 1. 1 minus 1 is 0. And 23, the x is 0. So 0 minus 1 is negative. So therefore, it's not there. So the first derivative when it's equals to 0 gives us a value of 3 and 5 over 3. Then we substitute the value of x into the cost function. So when x equals to 3, C3 is equals to 30 in bracket 3 plus 30 times 10 in bracket 3 square minus 8 times 3 plus 23, which gives a value of 9,600 ringgit. While at x equals to 5 over 3, C5 over 3 gives us a value of 9,955 and 60 cents. Therefore, we can conclude that it is cheaper at interval x equals to 3 with 9,600 ringgit.
In conclusion, based on this project, in order of learning the application of differentiation, we can see that it is very important in engineering as much as in other fields too. Furthermore, all this understanding can be shown on how we apply the differential concept in our life as civil engineering. By using this application, there are much more things that can be solved and also making more new projects, knowing that math doesn't have any boundaries when being used in our daily life, including this kind of project.